Started, are there any questions over the last homework assignment? And I think there's a question on number 17. Yeah, so let's look at 17 first. Because again, at the start of each lesson, I will look at 1 to 3 questions that y'all have on any of the previous assignments and go over them. So number 17, plane P and line K intersect at a point. So the first thing we need is a plane, and we'll call it P. Now, it intersects a line, and they're calling it line L at a point. That's it. Yes. And that's actually all it wanted. (23) Plane A and plane B are not intersecting. Yeah. 19. So 19, ray AB and line AC. So we can start off with the line. So we have a line and it has 2 points on it. One of them is A and one of them is C. So I drew the line AC. Now we also have a ray that's called AB. Now you could have put this point above it, below it, anywhere as long as it's not on the line. Actually, you probably could have put it on the line. That's one possible setup, because I could have put the point B down here somewhere or over here or anywhere and just made a ray. So 21 would be like 17, but instead of having 2 arrows, we'd have a point. So I can actually change 17 to 21. Make this into a point. Call it N. Call this B. And then this is plane M. Any other questions over the homework? Are you ready for the next section? Yeah, y'all can turn it in on my desk. So whenever you get the homework done, you can just turn it in on my desk. Normally there will be a pile. Okay. I'll take both. So if you want to hand it to me, you can. Or whenever you come in, if you just want to put a pile on my desk, that works too. Yep. So everybody has the note sheet 1.2, yes? So the first thing we're looking at today, note sheet, yes. So the first thing that we have is a postulate or axiom. A postulate or axiom is a rule that is accepted without proof. An postulate or axiom is a rule that is accepted without proof. That means we don't have to prove it. We don't have to show that this postulate or axiom is true. We do not have to show that it's true. We just accept it as a fact, that it works. And a theorem is a rule that can be proven. Now, as we go through the semester, a lot to, if not all the theorems that we will come across, we will prove. We will, well, when I say we, I think I'm using more the royal we, as in I will show you and prove that they're true on the board. We don't have to do that. I'm not going to make you do the proofs or showing that they are true. I like going through the proofs with y'all so that you see that they're true, that you get an understanding of why they work the way that they do. Because a lot of the stuff that we do, if we know why it works, it makes more sense of why and how we use it. So we have postulates, we have axioms, we have theorems. Then we also have what they call lemma. You don't have to write this down, but a lemma is something that comes from a theorem. It's an interesting fact, so when we go and prove a theorem that it's true, a lemma is something that comes from it. So we'll cover this eventually, but y'all have already covered the Pythagorean theorem. Yes, a squared plus b squared equals c squared. And that's a theorem. That's something we can prove. A lemma coming from that is that if this is true, then it's a right triangle. Or we'll call it the converse. It's a nice, interesting fact that comes from a theorem. We call it a lemma. So there's other ones for these here. We won't really cover this here, but it's at least something that y'all will know. Now the first one is the ruler postulate. So you don't have to write all this down. That's a lot of words. But let's look at what it says. So ruler postulate. 2 points on a line can be matched 1 to 1 with a real number. The real number that corresponds to a point is the coordinate of a point. I can take 2 points on a line and match it to a coordinate. I can say that this is 6 and this is 8. So the distance between them is? Really all this is saying. Right, so 2 points on a line. So A and B can be matched to coordinate points. Like on a ruler, we can match them to the coordinate, their numbered value, and then we can use that to find the distance. That's all this is saying. The distance between AB is written as AB, the absolute value of the difference between the two. So if we said that this is 6 and this is 8, we can say the absolute value of 6 minus 8, which is 2. Now, most of the time we don't use the ruler postulate like this. Assigning it 2 values and taking the absolute value of the distance. Because if I were going to use a ruler and measure this, by this definition, so this might be a little different because just scale. What they're saying is I could take this ruler, match S up to 3. Let's see if it works better in inches. Nope. Match S up to 3. And this is, so 6.5, 3. And then we could do 3 minus 6.5 to find its length, yes? Yeah. Is that how y'all would measure this? No, how would we actually do this? Because normally we would put one of the points at 0, kind of put it in the center, yes? And then we can measure it this way. Because what we're saying is not this, and well, it's not really 6.5. It actually works out a little bit nicer. Because really we can say that this is 0. This actually looks to be 3.4, yes? So what's the actual distance?
mathematically, we would say that we're taking the absolute value of 3.4 minus 0, which is just absolute value of 3.4, which is yeah, because the scale for the screen is a little off. So go on and measure it and see what you get. Because again, I would go centimeters because inches is not always nice. Centimeters works a little bit better. Yeah, write what you get because obviously this is not going to be the same scale. Because hopefully I'll all get something close to the same thing. Somewhere between 5.2 and 5.4. Yeah. Somewhere between 5.2 and 5.4 centimeters. Well, that's it. Questions on this here? Yay. We're able to measure with a ruler, yes? We're going to go on and move on because I don't think we need to go over rulers too much more, do we? Do y'all know the reason behind, y'all used a measuring tape before, yes? A little metal piece, do you know why it actually has some give in it? It goes back and forth? Yep. Because if you use it and attach it to an endpoint, and pull it, it actually zeroes it out. And if you put it up against something, it moves it in, so it is exactly 0. So it'll make up the difference for those two. More that you know. How many know what this tool is here? It is a compass. It's a compass. Mm-hmm. If you've seen movies where they kind of had, or kind of naval movies or with a ship where they have the map and they'll use this to kind of walk across it.
Oh, I thought that was for like if you like trying to draw like a
circle. It is used for circles, but they will use it on maps because if you've seen a scale at the bottom of a map, kind of how many miles for every inch or so, we could use it for this too. Because what I can do with this is if I want to reconstruct a line or distance, so I can make a line here. Now I can come up here, the pointer back again, and I will open this. Apparently I'm still doing circles. And put one point on A and then one point on B. And what this will do is it will recreate that line segment. So what I can do now is I can bring this over here and put it right here. And there, right here, this here is the exact same distance from A to B. So if we wanted to use it on a map, I can open it to the amount of miles equivalent to it and use this to actually piece out how far something is on a map, because it can recreate a line. Questions on this here? Luckily for y'all, we don't do a whole lot with creating or constructing in here, mainly because it does take a lot of time to do that. I'll get one out. Oh, yeah. So it does take a lot of time to use these. We do have several. A lot of the ones we have aren't as in good a shape, so they don't work as well. Some of them don't stay on the same one. This one's a little bit rusted, but also they are a little sharp. So, no. If If that was concrete, that'd be really impressive. But we don't do too much with the compass. Okay, so we can create lines, we can copy shapes, we can copy figures with them. So they're used for copying. And I'll get those out or get one similar to it out when we start doing a lot of the proofs, especially with triangles or copying shapes, and kind of show you how they work. Get out an old piece of technology called an overhead projector and do those on it. So the next thing we're looking at is congruent segments. Well, what does congruent mean? Equal, the same. Line segments that have the same length are called congruent segments. So if two segments are the same, then they are congruent. Congruent segments have the same length. So that's the main thing I would put. Congruent segments have the same length. Because you could put down line segments that have the same length are called congruent segments. You can say the length AB is equal to the length CD, length of CD. Or you can say that AB is congruent to CD. Now the symbol here, this symbol here means congruent. When we use this symbol, we're talking about the segments themselves. We're talking about the segments themselves being congruent. So when we say that AB, line segment AB is congruent to line segment CD, we're talking about the segment itself. It's not an actual length. We're saying that this segment and this segment are congruent. They are the same figure. Here, AB equals CD, where we don't have the segment above it, and it's just saying equal. This, we're talking about the distance. Without the line segment above it, we're saying that the actual length from A to B, that measure, that numerical number, is equal to the numerical number for CD. So when we write it like this here with line segment AB is congruent to line segment CD, we're talking about the line, not its length. But if we say that the two segments are congruent, it means that they are equal. Because for two segments to be congruent, it means they have to have the same length. You all see the distinction between those two there. If we're talking about a segment's length, that the fact that AB is 6 inches, or has a length of 6, we would say AB, we wouldn't include the line segment above it, equals 6, because we're talking about its length, its measure. If we include the line segment above it, we're talking about the figure. Do you all see the distinction between those two? So if I said AB is 6 units, I would say AB is equal to 6, because that's its length, its measure. If I say line segment AB, I'm talking about the line itself. Without the line, it's length. With the line, it's the segment. Because that's the main distinction between those two. So when we want to say we find the measure of a length, we don't need the line segment above it, because we're talking about its measure. If we're talking about the figure, that line segment AB and CD are congruent, then we need to include it because we're talking about the figure itself, not its measure. I mean, we're talking fine details, but y'all see the difference between those two, yes? Now, for this homework assignment, I will give you guys graph paper, because it's going to be easier to work with on graph paper. So, we're going to plot these points in the coordinate plane, and then we want to determine whether the two lengths are congruent, whether the two figures are congruent. So the first thing we'll want to do is plot the points. So point J is at -3, -1, -2, -3, 4. And this is point J. K is at the point 2, 4. Over 2. Questions? Yeah. So J to K So we have a straight line here. Now we can look at point L, which is over 1 and up 3. And M is 1, negative 2, so over 1, down 2. Any questions on how we plotted these here? So hopefully this is a refresher for what y'all did in Algebra 1, because I believe y'all plotted points in Algebra 1, 8th grade math. Y'all plotted points before. Okay. Now for them to be congruent, they have to have the same length, yes? We can count the grid. Yeah, the ruler was only for that first problem. We don't need the ruler after that. Now, if it's on a straight line, we can just count the coordinate points. We can go 1, 2, 3, 4, 5. So this has a length of 1, 2, 3, 4. So are they congruent? Yes. Yes. And for us to say congruent, we can say that JK, and we put the line segment above it because we're talking about the segment itself, is congruent to our equal line sign with a little squiggle line above it, is congruent to.
Wait, do we have to add that square line?
Yes. If it doesn't look perfect, that's fine.
What does that even mean? That square line?
So with the equal sign means congruent. Because equals, we're talking about quantities, numbers. So here, this is talking about the figures themselves. So when we talk about congruency, we use this here. If we drop the equal sign and just have the little squiggle line, we're talking about similarity. It's similar. So it might not be the exact same size. One might be bigger or smaller than the other, but they are similar to each other. Questions on this here? Yes?
What is this congruent?
Yeah, if they're equal, we're talking about the measures. We won't, let's see here, let me erase. If we're just saying that they're equal, we would put this. Because this would say that the length of JK is equal to the length of LM. But here we're saying that the two figures are congruent. Plot. Let's do another one. So we're going to plot these 4 points and then determine if the two line segments are congruent. So A is at negative 2, 4. B is at 3, 4. So this is A, this is B, and we do have line segment 3, 4. So 3, 4 is B. A is negative 2, 4. C is 0, 2. So we go 0 and up 2. And D is at 0, negative 2. C, D. Now luckily, again, we're on the straight line. We're on the axes. We're not going at a diagonal. So we can count the boxes.
Will it always be in the
1,
straight line?
2. Because we do have some that will go on a diagonal. But what we can use is the distance formula. I'll write that back up here and I'll put it on the smart board here in a minute. Because the distance formula, our square root of x2 minus x1. But I believe y'all have used this before. Because we plug the x values in, the y values in, and then it's plug it in the calculator. Distance. And we'll put it up here. I'll put it up on the smart board, so if you're rewatching the video, it will get back up here when we need it, because we don't need it yet. Now we can look at the other one, because it's straight down 1, 2, 3. No. And we could say that AB so what did we do to show that something's not equal?
Just like cut it out.
All right, we put a line through the equal sign, yes? So we do the same thing here. So that there is not equal, or not congruent, sorry. It's not congruent. Because they don't have the same length. That's it. Yep. And most, it's that way. Most students find algebra easier than geometry, and some find geometry easier.
Saying geometry is easier than algebra.
I could do a lot of
Questions on this here? Okay. All right, guys. We're going to keep going. We got our next postulate. Yep. Okay. Using the segment addition postulate. Let's see here. Okay. Okay. You guys ready for this? We're going to get to this part here in a minute. Now, when 3 points are collinear, so collinear means they're on the same line, yes? You can say that 1 point is between the other two. So if we have 3 points on a line, 3 points on a line, yes? One of those points will be between the other two.
That's all. It still counts as collinear.
Yep. Because again, so if I have 3 points that are on the same line, yes, one of them is going to have to be between the other two. Okay. We need that understanding for the segment addition postulate. If B is between A and C, so y'all can write this if you want. Just give me a second and we'll explain through it. And then you can write kind of your translation of it, okay? So here it says if A is between A and C, then AB plus BC will give us AC.
So it's like dividing the distances and just adding the distance to get the other distances.
Let me
You
get,
know what I'm trying to say?
yes.
I know I sound angry now.
So I drew two colors. So if AB, so the red line, and I take its length and add it to the green line, I get the whole thing. That's the segment addition postulate. If I take this part's length and add it to this part's length, I get the whole length. AC, yep. So DF is the whole thing, yes? So according to the postulate,
Then all we have to do is just add those numbers.
yeah, is equal to DF. Or really, 23
3
plus
35 equals
or most of the points we'll have are capital. Or really, what are we doing? 23 plus 35 is 58. And you,
You think it's for yourself. I do not think it's for yourself.
58. Questions on this here? Okay. I wrote this first one down just as kind of showing what the postulate or what this is showing. You don't have to write that every time. GH.
You have to subtract those to get that.
So I'm going to show it there, this here with by the definition, okay? Because if we did this by the geometric mathematical definition, what we're saying is that the length FG plus the length of GH equals FH. FH is 36. FG so we have this here. So the part that we're missing is GH. So what we can do is we can subtract 21 from both sides, because 21 minus 21 is 0, leaving us with just GH. 36 minus 21 is or what could we have done? We could have subtracted 21 from. I get a highlighter. Which is exactly that step right there. We're subtracting 21 from 36. Questions on this here? Use the segment addition postulate to find XZ. What would we do? Yes. Okay. Yep. I will post, so Google Classroom will have the assignment because we're pretty much done. Because that's really it. The last of them are just using this postulate.
So we don't
Yep. So for y'all, if you want the assignment, let's see here.
3 through 6 and 9 through 19.
Odd. 9 through 19 odd.
So,
Question on what statement? Yeah. Yeah, because they have work release. So it will be off of that. So it's not going to be all those problems, but the Google Classroom, y'all remember joining that? So on there, I do post pretty much, it will be, if you guys look it up, 8-18, chapter 1.2. If you missed class today, you need to go and watch the geometry chapter 1.2 lesson video and then complete the assignment on page this, problems, this. So I posted up there too. We'll get to it just here in a second. No, no. So use the segment addition postulate to find XZ. So to find the whole length, we add 50 and 23. So, yeah, here it wants to find the whole length. So these two parts add together. So XZ is questions on this here. So there is another question, as y'all can see. There's something covered up. We ready for the next part of this here? So you guys don't have to write this down. We can talk through this one. In the diagram, YW is 30. Can you use the segment addition postulate to find the distance between W and Z?
you just add like 30 and 50.
Yeah.
30 and 50 and it gives you.
So with this here, if B is between A and C, yes? So we're talking about the 3 points have to be what? Collinear, yes? They have to be on the same line.
Oh, wait, so
Are these on the same line? No. Right, we would have to use a Pythagorean theorem. We'd have to use another formula. And unfortunately, we can't assume this is workable by Pythagoras' theorem, because for Pythagorean theorem to work, the triangle has to be a right triangle. Since we're not told that that's a right angle, we cannot assume it. No. So, can we actually use the addition postulate for this? No. Yes. Yes. Here? Okay. Yeah, I mean, it would be tempting to try to use Pythagoras' theorem, a squared plus b squared is equal to c squared for this. But because we don't know it's a right triangle, we can't use it. That's the one stipulation for this here. Let's look at this one here. And again, I'm going to start redoing these slides so they're not just absolutely blurry. What would we do to find the length of KL? So we're going to subtract because they're giving us the whole, and we know one of the parts, so we're going to subtract to find the other. So what did they give us? Did they give us the two parts or a part and a whole? So to find the other part, we would subtract. If we're wanting to find the whole, we would add. Questions on this here? The cities shown on the map lie approximately in a straight line. Find the distance from Tulsa, Oklahoma to St. Louis, Missouri.
Okay, so it's just subtract again.
Because they gave us the whole length, yes? So the whole length is 738. 370, yep. Do we need to see another one of these here? Yep, and I think I gave them the wrong assignment. Hold on a second before you write that down. I want to look at. Yep, nope, this is what I want. I don't want 3 through 6. Yep. Well, I gave them the wrong assignment. Oh well.
Wait, do we need our rulers?
No.
Actually, I'll take the whole class. I mean, the ruler. All these.
So 9 through 12, 15 through 23. So the 3 through, because any of the ones that require ruler, I got rid of because I'm not making y'all have a ruler or try to recopy those. 15 through 23. Yep. Yep. So you can put it all on the graph paper if you want. So you can put it on my computer. Yep. You got some? You can start working on it now. I'm giving you graph paper so that you can graph it because finding the points.
Oh, no, I don't want to.
You're welcome. Because I think they're going to. You're welcome.
Oh, okay.
Thank you.